Welcome, everyone. It is Thursday, March 5th, 2026. And I have to tell you, the sheer volume of artificial intelligence developments dropping this week is
It's absolutely staggering.
staggering. Yeah. And honestly, it is a little bit daunting.
Oh, completely.
Like, if you've been feeling overwhelmed every time you open your tech feeds lately, you are definitely not alone. It feels like every single morning there's a brand new frontier model.
Or a totally new benchmark record being completely shattered.
Right. Or some massive shift in the underlying economics of the entire tech industry. We are witnessing this incredible explosion of progress, but keeping up with it, actually understanding what matters and what is just, marketing noise, it can feel like a full-time job.
It truly is a unique moment in the history of technology. I mean, the pace of iteration has accelerated to a point where even seasoned industry veterans, the people actually building these systems, are struggling to contextualize all the moving pieces.
Yeah, it's moving that fast.
The landscape we are looking at today, in March of 2026, is fundamentally different from the one we were navigating just 6 months ago. The paradigms are shifting right under our feet.
Which is exactly why we designed this deep dive specifically for you. You have a job to do, you have products to build, and you don't have, 40 hours a week to dedicate to reading dense AI research papers.
No one does.
Right. So our mission today is to cut through that massive wall of noise. We want to serve as your ultimate shortcut to being comprehensively well-informed on the absolute state of the art across text models, coding assistants, and the rapidly evolving computationally heavy video generation space.
Exactly.
You don't have to read the white papers. You don't have to parse the complex benchmark tables. We've done all of that heavy lifting for you.
And we have compiled a very robust, very diverse stack of sources for today's analysis to ensure we're giving you the full picture.
The stack is huge today.
It is. We'll be drawing heavily on comprehensive benchmark reports from Serenity's AI, deep dive coding analysis from the developer platform Zoer, fascinating economic and architectural breakdowns from Intuition Labs.
Highly detailed video model comparisons from the Laozang AI blog.
Yes, and crucial studies on the reality of context windows from LVEX, and of course the literal breaking release notes that Microsoft and OpenAI published just hours ago.
Hours ago. It is a massive stack of intelligence. And to set the stage for you before we get into the deep technical weeds, I think the biggest takeaway, the overarching theme of everything we're about to discuss from all these disparate sources, is that the era of just use one model for everything is officially dead and buried.
I completely agree with that assessment. If we look at the data across all these diverse sources, the trend is undeniable. We have definitively entered an era of hyper-specialization. We are also seeing extreme cost wars that are reshaping both the hardware and software markets, and a massive industry-wide shift toward agentic workflows. For you, the user, it is no longer about finding the single smartest chatbot to answer your questions.
Right.
It is about orchestrating the right specialized engine for the right specific task at the exact right price point.
Okay, let's unpack this right away because we have some massive breaking news to start with. Literally today, as we are recording this on March 5th, OpenAI just dropped GPT 5.4.
Hot off the presses.
We have the technical breakdowns from the new stack and 9 to 5 Google, and this is a major release. It comes in two distinct tiers, GPT 5.4 Thinking and GPT 5.4 Pro.
Two very different beasts.
Yeah, but the first thing that jumps off the page before we even talk about how smart it is the pricing shift. The Thinking model is coming in at $2.50 per million input tokens and $15 per million output tokens.
Which is somewhat competitive.
But the Pro model, that is a massive $30 for input and $180 for output per million tokens. I have to play devil's advocate here.
Oh, yes.
In an era where open source models are getting incredibly cheap, who on earth is paying $180 per million output tokens? That seems exorbitant.
It is a significant premium, particularly when you look at the broader market trends driving costs down, which we will discuss later. However, OpenAI is justifying that aggressive price point with some very bold claims about absolute reliability.
Reliability is the key word there.
Precisely. According to their release notes, GPT 5.4 is 18% less likely to contain logical errors and a full 33% less likely to produce false information or hallucinations compared to its immediate predecessor, GPT 5.2.
Wow.
They are explicitly positioning this not as a general chatbot, but as an enterprise-grade tool for high-stakes knowledge work.
So it's not for writing emails.
Definitely not. To prove this, they ran it through an internal benchmark designed to mimic the exact daily spreadsheet tasks of a junior investment banker.
Okay.
We are talking about parsing messy financial documents, cross-referencing complex discounted cash flow models, and looking for subtle data discrepancies. On that highly specific, highly complex task, this model scored 87.5%.
87%. So they are essentially trying to sell you a junior investment banker in a box.
Effectively, yes.
When a human junior banker makes a mistake on a pitch deck at 3 a.m., it can cost a firm millions. So from that perspective, paying a few dollars for a perfectly accurate spreadsheet review suddenly doesn't seem so expensive.
It changes the value proposition entirely.
It really does.
Exactly.
Here's where it gets really interesting, though. The standout feature of this new thinking tier isn't just that it's smart. It actually shows you an upfront plan of its thought process before it executes the final output.
What's fascinating here is how this fundamentally changes the user interaction paradigm. Historically, interacting with a large language model has been a bit of a black box.
You just type and pray.
Exactly. You provide a prompt, you wait in suspense, and you hope the output aligns with your intent. If the model misinterprets your prompt and goes off the rails in the very first sentence, you are entirely helpless.
You just have to sit there and watch it generate garbage.
You still have to wait for it to finish generating, and more importantly, you still pay for all the compute it used to generate that useless, incorrect response.
Yes.
By exposing the initial planning phase, GTC 5.4 thinking introduces a crucial element of mid-response steerability.
Let me try to visualize this for you because it really changes how you interact with the machine. Think of the old AI models like getting into a taxi in a foreign city.
Okay, I like this.
The driver immediately locks the doors, puts on a blindfold based on your very first instruction, and just floors the gas pedal. You have absolutely no idea what route they're taking, you can't talk to them, and you just have to sit there until you arrive, or don't arrive, at your destination.
And you get charged for the whole ride, regardless of whether they took a massive detour.
Exactly. You pay for the whole terrible trip. This new GPT 5.4 model is completely different. It's like a driver who pulls up the GPS on the dashboard, shows you the exact turn-by-turn route they plan to take, and actually lets you change the destination or the route while you are sitting at a red light.
That's a great way to put it.
If you see their logic taking a wrong turn, you can reach out, tap the screen, and correct the steering wheel before they burn through thousands of your expensive tokens going down a dead-end street.
That is an excellent way to frame it. And to take your taxi analogy a step further, imagine being able to tell the driver halfway through the trip, actually, skip the highway. Let's take the scenic route because my priorities just changed.
Yes, you're altering the computational path in real time.
When you, as a developer, are dealing with complex, multi-step agentic workflows where an AI is calling other APIs and making decisions, that ability to intervene is critical for cost control.
And speaking of tokens and scale, it is also worth noting in the release notes that OpenAI has officially removed the beta label for their 1 million token context window.
It is now generally available.
Which sounds great, right? But there is a very important caveat for developers using Codex, their programming interface. Any requests that exceed 272,000 tokens will be counted against your usage limits at a 2x rate.
A massive penalty.
Right. So while the capacity to dump massive amounts of code into the model is there, the economic penalty for actually doing it is substantial.
Which perfectly illustrates that constant underlying tension in the AI space between raw capability and practical cost.
So what does this all mean? You have this brand new, highly expensive, highly capable GPT 5.4 dropping today. But how does it actually stack up against the models that were dominating the developer landscape just yesterday?
Very valid question.
Because if you are building software right now, the coding arena is where the real heavyweight battles are happening. We aren't just writing emails anymore. We are asking these models to build entire software architectures.
Exactly. And to truly understand that specific landscape, we need to look closely at the comprehensive reports from Zor and the benchmark tables from Serenity's AI.
Let's get into the numbers.
If we look at market confidence for coding as of early March 2026, Anthropic's Claude Opus 4.6 is currently holding the crown. It commands 41% market confidence among professional developers, while OpenAI is trailing slightly at 33%.
When you dig into the Serenity's AI benchmarks, you don't just see that Claude is winning. You see exactly why Claude is winning that mindshare.
The specifics are crucial here.
Claude Opus 4.6 shines incredibly brightly when it comes to architectural reasoning. We are talking about a 92.1% accuracy rate for system architecture design.
That's exceptionally high.
It is the model you want when you need to catch cascading system errors or when you need to refactor a massive multi-file legacy codebase. But the stat that really blew my mind from the outline is its performance on SW Bench. The report says it is SWE Bench verified at 80.8%.
Yes.
Can you break down for the listener what SW Bench actually is and why scoring 80% on it is such a big deal?
Certainly. StarUI Bench is not your standard simple coding test where you ask an AI to write a quick Python script to reverse a string.
Right, it's not a toy benchmark.
SWE Bench is widely considered one of the most rigorous evaluations of software engineering capabilities. It tests models on real, historical GitHub issues from massive, popular open-source repositories like Django or scikit-learn.
Real-world problems.
Exactly. The AI is given the raw issue description from a user complaining about a bug, and it has to autonomously navigate the entire multi-megabyte code base, locate the specific file causing the issue, understand the complex interplay of the logic, write the precise fix, and then successfully pass the hidden unit tests.
And it does all that on its own.
For Claude Opus 4.6 to successfully resolve 80.8% of these complex real-world repository-level issues is astounding. It proves it can handle the sprawling, messy reality of enterprise software.
That is incredible context. So Claude is basically acting as a senior principal engineer. But the competition is incredibly fierce, and no one holds the crown for long. Just a couple of weeks ago, on February 19th, Google released Gemini 3.1 Pro, and it immediately disrupted the rankings.
It absolutely did.
It boasts a massive 1 million token context window natively, and it absolutely crushed the Live Code Bench Pro benchmark. Now, Live Code Bench uses an ELO rating system, much like competitive chess, to rank competitive programming ability.
Right, to see who is truly the best head-to-head.
Gemini 3.1 Pro hit an ELO of 2887, which is a massive leap over GPT 5.2's 2393. But what really caught my eye is that Gemini dominates in UI to code translation, hitting 91.8% accuracy.
That UI to code metric is vital for front-end developers. It means you can feed Gemini a complex visual mock-up from Figma, a static image of a user interface, and it will generate the pixel-perfect HTML, CSS, and React code with nearly 92% accuracy.
Got a picture.
Yes. But we also need to look at how Gemini 3.1 Pro performs on the ARC AGI2 benchmark, where it scored 77.1%.
Okay, let's unpack this right here because I want to make sure we don't just throw alphabet soup at the listener. What is the ARC AGI2 benchmark? And why should a developer care about a 77.1% score?
The Abstraction and Reasoning Corpus, or ARC, is designed to test novel pattern recognition.
Okay.
Unlike many benchmarks that test memorized knowledge, ARC presents visual, grid-based logic puzzles that the AI has never seen before in its training data. It requires the AI to infer underlying rules from a few examples and apply them to a new situation.
So it can't just cheat by having read the answer on Reddit during training.
Exactly. It is something humans generally find quite intuitive, but AI has historically found impossibly difficult because it requires genuine abstract reasoning rather than just pattern matching from training data. For Gemini to hit 77.1% means it is developing a robust ability to generalize and think abstractly about novel problems.
So if we step back and look at this fragmentation of the frontier models, it breaks down into these incredible, highly specialized roles. You have Claude Opus 4.6 acting as the architect.
The systems thinker.
Right. If you're building a secure microservices architecture or designing a complex database schema where one mistake ruins everything, Claude is your go-to. Then you have Gemini 3.1 Pro acting as the prototyper and abstract thinker.
Yes.
If you have a Figma mockup and you need that UI code immediately or you need to solve a novel logic puzzle, Gemini is your champion.
And we must not overlook Anthropic's mid-tier model, Claude Sonnet 4.6, which has quietly become the ultimate autonomous worker.
Oh, this is a fascinating point.
In the Agentic GDP Valley A ELO rankings, Sonnet 4.6 scored 1633. Now, that specific benchmark measures how well a model operates autonomously in multi-step workflows, where it is given a high-level goal and has to independently figure out the subtasks, execute them, check its own work, and iterate.
And how did it compare to the bigger models?
What is remarkable here is that Sonnet 4.6's score of 1633 actually beats its more expensive larger sibling, Opus 4.6.
That's wild.
It is a counterintuitive finding. The cheaper mid-tier model is actually better at autonomous agentic task completion than the flagship model.
Which brings us right back to that core theme. You, as the developer, the startup founder, or the project manager, aren't just choosing one subtle model anymore.
You can't.
The Zoer coding report highlights this massive industry-wide trend toward multi-model orchestration. Entire platforms are literally being built with the sole purpose of routing different parts of a single user prompt to entirely different models behind the scenes.
The routing layer is everything now.
You might type one sentence, but the orchestration layer uses Claude Opus to design your complex, secure database schema. Then the system automatically hands off the front-end UI generation to Gemini 3.1 Pro because it is demonstrably better at it.
And then it routes all the simple, routine, autocomplete coding tasks to a much cheaper model like Sonnet. If we connect this to the bigger picture, this orchestration trend is fundamentally changing software economics. Developers are realizing that paying premium rates like the $30 per million input tokens we just saw for GPT 5.4 Pro for routine boilerplate code is an incredible waste of resources.
It makes no sense.
It is like hiring a senior partner at a law firm to proofread a basic email.
Yeah.
You are paying for a level of intelligence that the task simply does not require.
Exactly. I want you to reflect on your own daily workflow for a second. Think about the AI tools you are currently paying for. Are you paying absolute premium, flagship prices to a model that isn't even specialized for the exact task you are doing?
A lot of people are.
Are you using an architect to do a prototyper's job? Are you using a $30 model to do basic autocomplete? Because if you are bleeding money unnecessarily.
And that economic pressure, that realization that you don't need a sledgehammer to crack a nut, is what makes our next topic so critical. Because while OpenAI, Anthropic, and Google are fighting over dominance in the premium tier, there is a massive structural disruption happening at the foundational level of AI economics.
A cost wars.
And it is being driven primarily by DeepSeek.
Here's where it gets really interesting. Let's talk about the secret weapon of cost. We're pulling this from a fantastic, deeply researched economic deep dive by intuitionlabs.ai. DeepSeek has completely upended the pricing tables with their V3 and V3.2 models.
They've rewritten the rules.
Now, to be clear, these are massive, highly capable models. V3 is 671 billion parameters, and V3.2 is 685 billion parameters. V3.2 even introduces a new capability they call thinking in tool use, allowing it to deeply reason about how and when to use external APIs. But the absolute headline here is the cost. It is staggeringly, almost unbelievably low.
We're talking about 14 cents per million input tokens and 28 cents per million output tokens.
Cents.
Let's put that in perspective for a moment. That is roughly 20 to 50 times cheaper than OpenAI's comparable frontier models. And perhaps even more shockingly, Intuition Labs notes that training their specialized reasoning model, R1, reportedly cost only about $294,000 using a cluster of 512 H800 chips.
That's pocket change in Silicon Valley.
When you compare that to the hundreds of millions, sometimes billions of dollars being poured into massive training clusters by Western tech giants, it is a paradigm-shifting data point. It proves that massive compute budgets are not the only prerequisite for intelligence.
Okay, I have to stop you there because the listener's probably thinking the exact same thing I am. How on earth are they doing it? How do you get a massive 671 billion parameter model to run for literal pennies? Are they just taking a massive loss to gain market share?
While loss leading is a common tech strategy, the core of DeepSeek's pricing advantage comes down to brilliant architectural optimization. Specifically, their implementation of the mixture of experts, or MoE architecture.
Okay, tell me more.
Let me break this down. Even though DeepSeek V3 has 671 billion parameters in total, it does not use all of them for every single word it generates. Instead, the model is divided into specialized expert subnetworks.
So it's like a massive hospital. You don't need every single doctor in the building to look at your sprained ankle.
Precisely. In this analogy, when you send the model a prompt, a highly efficient routing mechanism acts as the triage nurse. It determines which specific experts, say, the Python coding expert or the French translation expert, are needed for that exact topic.
I see.
Because of this routing, DeepSeek V3 only activates about 37 billion parameters per request. So you get the vast comprehensive knowledge base of a massive 671 billion parameter model, but you only incur the computational cost and energy draw of a much smaller 37 billion parameter model.
That is brilliant engineering. But here's where it gets really interesting for developers who are running high-volume, real-world applications. The Intuition Labs report explains a feature called context caching on disk, and it is an absolute game changer.
Oh, this is massive.
Imagine you have built a multi-turn chatbot for your company's customer service. Every single time the user sends a new message in the chat, the API has to reread the entire history of the conversation, plus your massive system prompt from the very beginning.
Which costs money every single time.
DeepSeek essentially saves or caches those duplicate input segments on their physical disk. If the system recognizes the prefix of your prompt, like that massive system prompt that never changes, it doesn't waste compute rereading it. It just pulls the mathematical representation directly from the cache.
And the economic impact of that caching mechanism is profound. According to the data, it drops the already rock-bottom cost by up to 90%.
90%.
So if you hit the cache, you're paying something like $0.014 per million tokens. Furthermore, Intuition Labs highlights that DeepSeek is heavily utilizing Neural Magic's 4-bit and 8-bit quantization.
Okay, quantization is another one of those intimidating technical terms. Can we give the listener a simple way to understand what that actually means?
Absolutely. Think of quantization like compressing a massive, high-resolution RAW photograph into a much smaller JPEG file.
Okay, I can picture that.
You are taking the mathematical precision of the model's parameters and compressing them from 16-bit down to 4-bit. You lose a tiny amount of absolute microscopic detail in the underlying math, but to the naked eye, or in this case, for the model's ability to reason effectively, the picture still looks exactly the same.
But it's a smaller file.
The massive benefit is that a 4-bit model takes up vastly less space in the GPU memory, and it loads significantly faster. By doing this, they are achieving up to 4x faster inference speeds without a noticeable loss in accuracy. Faster inference means the model spends less time taking up expensive GPU compute cycles, which translates directly to radically lower costs for the end user.
Let's put all of this into a real-world scenario so you can truly feel the impact of these numbers. The sources outline a highly realistic scenario. Imagine a startup running a popular social media companion chatbot with 1 million daily active users.
A very standard use case.
If you run that massive workload on a premium frontier OpenAI model, you might be looking at a monthly API bill of $150,000. For a lean startup, that is a massive, potentially fatal burn rate.
It's unsustainable for most.
But if you port that exact same workload over to DeepSeek and you heavily utilize that context caching for all the repetitive system prompts and conversation histories, that monthly bill drops from $150,000 to roughly $2,000.
That is not just an incremental saving. That is the difference between a viable, scalable business model and total bankruptcy. And the macro impact of this realization across the industry has been staggering.
Totally.
Intuition Labs reminds us of what happened in January 2025 when DeepSeek first released R1 and proved definitively that you didn't need a billion-dollar supercomputer cluster to achieve frontier-level reasoning.
It sent shockwaves.
It caused a $600 billion drop in NVIDIA's market cap in a single day. The global market suddenly woke up and realized that brute force compute, simply buying tens of thousands of the most expensive chips on Earth, wasn't the only path to advanced AI. Efficiency, algorithmic elegance, and optimization suddenly became the most valuable currency in the industry.
It's the classic innovator's dilemma playing out in real time in the AI space. The giants built massive, expensive infrastructure, and a leaner competitor found a way to bypass it entirely.
Exactly.
But, not everyone wants to rely on a cloud API, no matter how ridiculously cheap it is. If you're a bank, a healthcare provider, or a defense contractor, you have strict privacy concerns.
Data locality is a huge priority for them.
You might have stringent latency requirements, or you might need full offline capabilities. There are plenty of reasons you might want to run powerful models entirely on your own local hardware or within your own secure private cloud.
Which is exactly why the open source and medium model resurgence is the next crucial piece of this complex puzzle. And the very definition of what constitutes a medium model has shifted dramatically over the past year as these optimization techniques have improved.
Okay, let's unpack this because we have a great source from the Microsoft Community Hub detailing exactly this. The Qwen 3.5 Medium Model Series just landed in Microsoft Foundry, and it perfectly illustrates this massive trend toward powerful, locally hostable AI.
It's a very robust lineup.
This series features 3 key models, and the breakdown is fascinating. There is a 27 billion parameter dense model. There is a 35 billion parameter MOE model that only activates 3 billion parameters, and there is a massive 122 billion parameter MOE model that only activates 10 billion parameters per pass.
A wide range of options.
And all three of these models come standard with a massive 262,000 native context window, fluency in 201 languages, and early fusion multimodal training, making them vision language models right out of the box.
Yeah.
The architectural choices presented here are fascinating, especially when you compare the traditional dense model to the newer MOE models. A developer looking at this spec sheet might naturally ask, why would anyone choose to use the 27B dense model when the 35B MOE model is arguably smarter, has more total parameters, and only activates 3 billion parameters, making it cheaper and faster to run?
Right? It seems counterintuitive.
The answer comes down to one critical requirement: predictable latency. Because a dense model activates every single parameter for every single token it generates, the time it takes to generate a response is highly consistent.
Oh, I see.
If you're building a real-time voice application or a high-speed robotics control system, you cannot afford the variable latency, the occasional stutter that sometimes occurs when a MOE model has to dynamically route tokens to different experts. You need absolute consistency, and that is what the dense model provides.
But if sheer reasoning throughput and cost efficiency are your primary goals, and a few milliseconds of jitter don't matter, those MOE models are absolute magic.
They really are.
Take the 122B A10B model. The documentation shows it uses 256 different experts, 8 routed and 1 shared, but it only activates 10 billion parameters at a time. You are getting frontier-class, multimodal performance, the kind of deep reasoning that used to require a massive centralized cloud cluster, and you can run it incredibly cheaply on enterprise hardware.
If we connect this to the bigger picture, it fundamentally changes what is possible at the edge and within highly secure enterprise environments. The Microsoft source provides excellent, highly practical examples of this.
Let's hear them.
Imagine a high-speed manufacturing factory floor. You can deploy that highly predictable 27B dense model on a local server directly connected to a high-speed inspection camera over the conveyor belt.
Right on the floor.
Because it was trained with early fusion vision capabilities, meaning it intrinsically understands images and text together rather than just having a vision module bolted on as an afterthought. It can process the live video feed of a printed circuit board assembly line in real time. It can identify microscopic solder bridges, misaligned pads, or missing components with consistent millisecond latency without ever needing an internet connection.
That is an incredible industrial use case. And for a completely different scenario, let's look at the Microsoft example of an in-house investment team at a private equity firm.
A very different environment.
They don't care about real-time millisecond latency. They care about deep, flawless reasoning over complex, sensitive documents. They could deploy that massive 122B A10B model directly on their secure, air-gapped internal servers. They can feed it an entire 50-page deck of earnings slides as raw images.
The early fusion vision helps there too.
We are talking about messy PDFs with tiny footnotes and complex tables. The model can accurately extract the EBITDA trends, interpret the complex bar charts, and immediately flag subtle deviations from prior quarter guidance, all without ever sending a single byte of their highly confidential financial data to OpenAI, Google, or DeepSeek.
It is the true democratization of enterprise-grade AI. You no longer have to compromise security for intelligence.
Yeah.
But there is a hidden trap here that many developers and enterprise users are currently falling into.
A trap.
All of these models we have discussed, from Qwen to Gemini to Claude to OpenAI, are heavily marketing these massive context windows. We are seeing numbers like 262K, 1 million, even 10 million tokens.
Right. The LVEX report highlights this perfectly. Gemini 3 Pro and Llama 4 Scout are currently advertising 10 million token windows. GPT 4.1 has 1 million. You hear those massive numbers as a user and you think, this is fantastic. I can just upload my entire corporate archive, the entire legacy code base, all my emails from the last 5 years, and the AI will just absorb it and know everything instantly.
It's a very tempting thought.
But do they actually remember what you tell them when you stuff the context window that full? Are they actually reading every word?
This raises an important question, and it is arguably one of the most misunderstood aspects of modern AI capabilities. We have to look closely at the research from LVEX, which meticulously unpacks what they call the memory illusion.
The memory illusion.
The harsh reality is that a context window is not a perfect static hard drive. It is a highly volatile working memory. The LVEX data shows that most models degrade rapidly when you push them past 60 to 70% of their advertised maximum capacity.
Wait, hold on. Are you saying that Google and Meta are advertising a 10 million token window on the box? But if I actually put, say, 7 million tokens of crucial legal documents into it, it's essentially going to start hallucinating or completely forgetting the clauses I gave it. How are they getting away with marketing that?
They were marketing the theoretical technical capacity, not the practical retrieval reliability. It suffers from a well-documented phenomenon that researchers call the lost in the middle effect.
Lost in the middle.
Neural networks generally have strong recall for the very beginning of a prompt, the system instructions you give it first, and the very end of a prompt, which is the most recent text it processed right before generating an answer. But the massive chunk of information in the middle, those millions of tokens of context, gets incredibly hazy.
That's blurry.
The model's attention mechanism struggles to reliably retrieve specific facts buried deep inside a massive context payload. It might summarize the general theme correctly, but it will fail to find a specific data point hidden in page 4000.
There is one notable exception to this rule in the LVEX report, though, and it is worth highlighting. Anthropic's Claude 4 Sonnet. Now, it only has a 200,000 token window, which sounds incredibly small compared to 10 million, but the LVEX research shows it suffers less than 5% accuracy degradation across its entire window. It actually remembers what you put in there, from token 1 to token 200,000.
Which strongly reinforces the idea that raw numbers in marketing materials do not tell the whole story. Consistent, reliable retrieval often trumps raw, unreliable capacity.
So what does this all mean for you, the person actually trying to use these tools to get work done? How should you actually handle this memory illusion in your daily workflow? First and foremost, stop just blindly stuffing the context window with everything you have.
That doesn't work.
It is computationally expensive, it is slow, and it actively leads to worse, hallucinated results.
Exactly. You need to implement strategic context management rather than relying on brute force. First, utilize retrieval augmented generation, commonly known as RAG.
RAG is essential.
Instead of loading a massive 5,000-page technical manual into the prompt every single time a user asks a question, use a vector database to rapidly search the manual for the 3 specific pages relevant to the user's question, and only feed those 3 highly relevant pages to the AI.
Much smarter.
Second, use active context summarization. If you have a long-running chat session or a massive agentic loop, have a smaller, cheaper model periodically summarize the conversation history and feed that condensed summary back into the main prompt to save space and maintain focus.
And employ smart prompt engineering based specifically on that loss-in-the-middle effect. Put your most crucial, unbreakable system instructions at the very beginning of the prompt, and then repeat the specific question or the exact task constraints at the very end of the prompt.
Bookending the prompt.
Right. Don't bury the actual question you want answered in paragraph 400 of a massive document dump. The AI will forget what it was supposed to do by the time it reaches the end, and most importantly, match the tool to the job. You do not need to pay for a 10 million token window to summarize a 50,000 word document. Use a smaller, cheaper, highly consistent model like Claude Core Sonnet for that specific task.
Optimization and strategic orchestration are truly the names of the game in 2026. We have thoroughly explored how to optimize text models and coding agents, which rely on relatively lightweight tokens. But the frontier that is currently consuming the most compute, driving the most hardware innovation, and seeing the most dramatic visual leaps is the video generation space.
Yes. Let's shift our focus to the AI video revolution. We are moving beyond text and code into the heaviest data format on Earth.
It's a completely different scale of compute.
We have an incredibly detailed breakdown from the Lao Zhang AI blog that compares the top 5 players dominating the video space right now. Sora 2, Veo 3.1, Runway Gen 4.5, Kling 2.6, Hailu 2.3, and the new open source heavyweight Wan 2.2.
The video landscape has consolidated significantly over the last year, and just like we saw with the coding models, distinct specialties and tiers have emerged.
Okay, let's unpack this tier by tier.
If we start at the absolute high end of the market, we have OpenAI Sora 2. According to the Lao Zhang analysis, it remains the undisputed king of cinematic quality. Its core strength is its ability to maintain incredible motion coherence.
It doesn't get all glitchy.
It can keep a character's facial proportions and physical dimensions perfectly stable as they move dynamically through complex, highly detailed 3D space environments. However, that quality is heavily gated.
It's expensive.
You can only access the high-quality modes behind a very steep $200 per month ChatGPT Pro subscription. And crucially, There is currently no public pay-per-use API for developers to integrate it into external applications.
Which makes Sora 2 absolutely amazing if you are a creative director at an ad agency making a high-end short film, but it is basically useless if you're a developer trying to build an automated video application.
Exactly.
But then you look at VO 3.1 from Google, which the Laozang blog literally calls the developer's dream.
What's fascinating here is how strategically Google structured VO 3.1 for the enterprise and developer market. It is currently the only major frontier model offering native 4K output.
Native 4K is huge.
Furthermore, they provide exact, highly transparent per second API pricing. You can run it in fast mode for 15 cents per second of generated video, or you can run it in full 4K standard mode for 60 cents per second.
You know exactly what it's going to cost.
Yeah. This absolute transparency is crucial for businesses that need to calculate exact unit economics and profit margins for their apps. Beyond the pricing, VO 3.1 offers a highly unique first and last frame interpolation mode.
Oh, this feature is so incredibly cool. Let me explain how this actually works for you, because it changes the game. Usually, you give a video AI a text prompt or maybe one starting image, and it basically guesses where the video should go next. It hallucinates the motion.
Which can be very unpredictable.
With VO 3.1's first and last frame mode, you can give the AI an image of a rough block of marble as the starting frame and a second image of a beautiful, finished statue as the ending frame. The AI will then mathematically calculate and generate a perfectly smooth, logical video transition of that marble being actively carved into the statue.
It fills in the gaps.
For product marketing, visual effects, or precise scene transitions, that level of deterministic control is an absolute game changer.
It represents a fundamental shift. It moves video AI away from being an unpredictable slot machine, where you just type a prompt and hope for a good result, and turns it into a controllable professional rendering engine. Then we have Runway Gen 4.5, which is taking a different approach.
They're an ecosystem now.
They are positioning themselves not just as a standalone model, but as the ultimate creative ecosystem. In fact, Runway made a highly strategic decision to actually integrate Google's VO3 and VO 3.1 directly into their own platform via API.
Right. So with one Runway subscription, you don't just get Runway's proprietary models, you can seamlessly switch over and use VO's engine for a specific shot without ever leaving the Runway editor interface.
Very smart.
It is exactly that multi-model orchestration trend we saw in coding, now happening seamlessly in video. But let's be real, not everyone is rendering 4K cinematic commercials or complex visual effects. Let's say you're a social media manager, and your job is pumping out 15 highly engaging vertical TikToks a day. You do not want to pay 60 cents a second, and you certainly don't want to wait 10 minutes for a 4K render.
For that specific workflow, the Laozang blog identifies the undisputed budget and speed kings, Kling 2.6 and Hailu 2.3. Kling, in particular, has optimized its architecture for speed. It generates highly usable dynamic clips noticeably faster than Sora 2 or VO.
And it does vertical format really well.
Importantly, it has exceptional native support for vertical 9.16 social media formats. It even offers a generous free tier with refreshing monthly credits, making it highly accessible. The absolute visual fidelity might lack the microscopic cinematic details of Sora 2, but when the final video is being viewed on a 6-inch smartphone screen while scrolling on a bus, the viewer will rarely, if ever, notice the difference.
And finally, we have to talk about the open source video heavyweight, Wan 2.2 from Alibaba. It's actually built on that exact same highly efficient MoE architecture we talked about earlier with DeepSeek and Qwen.
If we connect this back to our earlier discussion on enterprise self-hosting and data privacy, Wan 2.2 is essentially the video equivalent of Qwen. It eliminates recurring cloud API subscription costs entirely.
You pay nothing per generation.
The significant trade-off, however, is hardware capability. Video generation is immensely heavy. You need a serious, dedicated GPU setup, ideally with 24 gigabytes of VRAM or more, just to run Wan 2.2 effectively. But for independent visual effects studios or enterprises with the technical expertise to manage the hardware, the long-term return on investment of self-hosting a video model that rivals commercial quality is immense.
Okay, let's look at the real bottom line costs here, because the Laozang blog actually ran the math for us, and it is eye-opening. If you want to generate a single 10-second video at 1080p resolution, here is what it actually costs you out of pocket. VO 3.1 in standard quality comes out to exactly $4.
$4 for 10 seconds.
Runway, using their internal credit system, comes out to roughly $1.20. Sora 2, if you estimate the cost based on the typical usage limits within that $200 monthly subscription, averages out to roughly $3.50 per video.
Those stark numbers highlight exactly why cost optimization and strategic orchestration are just as important in the video domain as they are in text encoding.
Exactly. And my direct advice to you is to be fiercely strategic with your budget. Do not generate a $6 fully rendered 4K video using VO 3.1 for a meme account on TikTok.
It's a complete waste.
The social platform is just going to aggressively compress it down to 1080p anyway, and you literally just burned your budget for extra pixels that nobody will ever see. Use Kling for the rapid daily socials, use Runway's ecosystem for drafting and storyboarding, and reserve the massive power of Sora or VO for the final high-definition client hero shot. Match the tool to the job.
It is the ultimate lesson of 2026. Algorithmic efficiency and workflow optimization are the new frontiers of competitive advantage.
Okay, let's take a deep breath because we have covered a truly massive amount of ground today. We started with the breaking news of OpenAI's GPT 5.4 dropping today, analyzing its steep $30 pricing but marveling at its incredible new ability to plan ahead and let you actively steer its thought process.
A major leap.
We look deeply into the intense fragmentation of the coding models, using Claude the Architect for structure and Gemini the Prototyper for UI. We uncovered the absolute economic disruption of DeepSeek's bottom-barrel pricing, their MOE architecture, and their brilliant context caching.
We faced the harsh, practical reality of the context window memory illusion.
And finally, we mapped out the highly tiered, highly specialized ecosystem of the AI video revolution.
The overarching narrative across all these diverse technical domains is crystal clear.
So what does this all mean? For you listening, the ultimate takeaway here is not to feel overwhelmed by all these benchmarks, parameters, and model names. The takeaway is to be strategic. The era where you were just a passive prompter typing a simple question into a single chat box is completely over.
That area is gone.
You are now an orchestrator. You are conducting a complex symphony of highly specialized, distinct cognitive engines to build your workflows, manage your compute budgets, and create applications and media that were literally impossible to make a year ago.
This raises an important question, though, and this is a final, somewhat provocative thought I want to leave you with. Building upon everything we've discussed today regarding agency and automation, as we move deeper into this era of agentic AI, where models like GPT 5.4 are proactively thinking ahead and correcting themselves, and platforms like Zoe are autonomously orchestrating multiple models to build entire software applications from a single descriptive sentence, what happens to the uniquely human skill of iteration?
That's a deep question.
Historically, the messy friction of drafting, reviewing, debugging, and refactoring is exactly where humans actually honed their deep expertise and discovered novel, unexpected solutions. If the machine now handles that entire closed loop of iteration autonomously, will humans inevitably transition from being the active creators of work to simply being the passive curators of machine-generated realities?
Just picking the best option.
And if your primary role shifts from actively building the product with your own hands to merely selecting the best version of a product generated by a cluster of AI models, how will that fundamentally change the way you derive value, satisfaction, and meaning from your own daily work?
Wow. From active creator to passive curator, that is a heavy, deeply fascinating thought to mull over, and it really changes how you look at the tools you use every single day. Thank you so much for joining us on this deep dive today. We hope this comprehensive breakdown has given you the clarity and the actionable insights you need to navigate this wild, rapidly changing landscape. Get out there, test these specialized tools, start ruthlessly optimizing those workflows, and above all, keep exploring. See you next time.